Hey AP Stats, it's Mr. Lineski. Today we are looking at ChiSquare Test of Homogeneity and ChiSquare Test of Independence. We looked at goodness of fit tests, and we had said that goodness of fit was whenever there is one variable that we're looking at, and we're either sort of testing a claim of sorts or testing whether or not things might be evenly distributed. So for a chi-square goodness of fit, basically what that's going to look like is that's going to look like a two-way table. It's when we have two variables. So in this particular problem, we are looking at gender, male, female. We're looking at income class level, low, medium, and high. So it says here that we take a random sample of 500 males and 450 females from your state, and we determine the income level for each individual. The data is summarized in the two-way table, and what we're asking is the distribution of income the same for males and females? And so when we're asking the question of is the distribution the same, that is a test of homogeneity. So for this, when we say that the distributions are the same, what that means is, let's say that 40% of males were in low income and 50% were in middle income and 10% were in high income, then we would expect the distribution to be the same for females, where it's 40 in low, 50 in middle, 10% in high. And so for that, our null is going to be that the distribution of income level is the same for males and females. The alternate would be that they are not the same. So to run this test, doing our 4-box method, so that's our box 1, our hypothesis. This one's a bit weird, where you almost have to run box 3 before you can check the conditions. So for this, what we're going to do is we're actually going to put this into a matrix. We're used to putting things into list 1 and list 2, but we're actually going to put them in the matrix. So on your calculator to do that, if you're just sort of on your home screen here, to do that, you're going to go to second and then hit the inverse button. That will take you to the matrix menu. Then you're going to go over to edit and just go ahead and select matrix A. Then you're going to type in the dimensions of your matrices, however big that may be. So this is a 2x3. And then all you're going to do is you're just going to type in the numbers that you see in the cells, and that kind of gets put in for each of those. So then what you actually do from here is you quit. And then you're going to go to stat, and then you're going to go to tests, and then you're actually going to run the test before we even do the conditions. And so for that, we're going to run just a chi-square test. So notice we're not doing the goodness of fit test anymore, chi-square test. So we still have observed matrix, and then what this actually does is it calculates the expected values for us, and it stores them in matrix B. So really, all you have to do is the observed matrix. And then you're just going to hit enter. And then I think it's a good idea to go ahead and jot down these numbers for your mechanics, because you're going to come back to them later. But you just need to remember that you still have to check conditions. So after we have that, so now we want to actually check our conditions. So the conditions are the exact same thing. It's still random sample. We still have counts of data. And then the expected values still have to be 5 or above. So the expected values, to check that, what you're going to do is you're going to go to the calculator. You're going to go back to the matrix menu, and if you remember, we said that it stored it in matrix B. And so for that, you can either check it out by going to names, or you can go to edit. I like going to edit because it actually shows it as a smaller version. If you go to names, it actually puts them up as very large digits, and sometimes you have to scroll, and it's kind of annoying. So I think it's easier just to look at it in terms of edit. So then you do have to go ahead and write those values down. You know, I like to just put them in the table like this. And so those are all of our expected values, and yes, they're all above 5. So because all those conditions are met, we will run the chi-square test of homogeneity. It is important that you specify which type of test you're running, so don't just say chi-square test, because we have 3 of them: goodness of fit, homogeneity, independence. If you notice, the degree of freedom came out to be 2. So just to kind of show you where that comes from, because you might be looking at this table and be like, well, where did they get 2 from? To calculate the degree of freedom when it's a table like this, you're actually going to use the formula, the number of rows minus 1 times the number of columns minus 1. And so our p-value was in scientific notation, so that's approximately 0. So p-value low, reject the null. There's enough evidence to support that the distribution of income is not the same for men and women. Okay, so moving on to test of independence. Test of independence is basically the exact same thing. The only difference is what we're asking. So for this one, it says, could eye color be a warning signal for hearing loss in patients suffering from meningitis? So for this, we're essentially asking, is there an association here? So before we were testing, are the distributions the same? Now we're testing, is there an association? So the test is going to be run in the exact same format. You're going to type the matrix into matrix A. It'll get stored in matrix B. You're still going to run that chi-squared test on the calculator. For the HOHA here, our null and alternate, we would say that eye color is independent of deafness-related meningitis, or that eye color is dependent. Another way you can say it is you can say eye color has no association to deafness-related meningitis, or you can say eye color has an association. Instead of dependent, you could also say not independent. So there's a lot of different ways you might see this. And the only reason I bring that up is because it sometimes comes up on multiple choice questions. You know, the wording's a bit different. But again, we are testing, is there an association? Conditions are exactly the same. We still have the random condition. We want our expected values to be 5 or above. And then we still want to make sure that we have counts of data, or that we're using sort of this categorical data. And so that's what we have. All those conditions are met. Chi-square test of independence. When we run it on the calculator, again, I'm not going to run this one, but it's the same thing. We would type this into matrix A. We would still run the chi-square test, which is option C. Still write those 3 things down for our mechanics. So for this one, p-value less than alpha, reject the null, you know the rest. Alrighty, thank you for watching.